any of these that you're never heard of before, need to go over again? These tend to be, didn't you cover these in like 9th grade Earth systems or something?
No.
Tiny.
So.
A little.
Possibly.
Yeah, you at least hear them. Teachers
but-
make references to them all the time.
Yeah,
They just
they
expect
make
you to know what they are.
we didn't, like, spend
Okay.
a great deal of time on it.
We always assume that you remember whatever you were taught in years previous.
Yeah, that's a big
Is
assumption.
that a faulty assumption?
Normally.
Okay.
Sometimes.
Let's see. So that's
Well,
what
those
they
all make
mean
sense,
by
so.
dynamics. This next one's kinematics.
Yeah.
Right? Okay. What kind of questions do they do? Are they super involved kinematics or are they very simple?
Oh,
You two are doing it.
like last. All right, would kinematics be gravity and the speed an elevator drops?
Yeah, unless they
These
have
are
it
the example questions that they give you.
Okay, so one would be 2. Okay. Well, if you want to look at, do you guys all have this?
You should, whether it's with them or not.
Somewhere in- Okay. Well, let's look at number 2 would have been one of these for Newton's laws. So, TJ, if you'll just read 2.
Okay, so it says 5.5 kilogram watermelon is pushed across the table. If the acceleration of the watermelon is 4.2 meters per second squared to the right, find the net external force exerted on the watermelon.
Okay, so which one of Newton's laws is this?
Second.
Second one,
Yeah,
yeah. So you just
F
have to go
equals
F
M.
equals MA. Which F here is already the net
Yeah.
force. Yeah, so just multiply those two.
23.1.
Do you really just do that in your head?
Mm-hmm.
He has the paper in front of him, and I'm sure he's already done that problem.
No, it's 23.1.
Oh.
You did that in your head, just
Yeah.
like that? Mark?
It's not complicated.
Well, if it's multiple choice, you could also go 4 times 5 is roughly 20, a little bit above 20.
Yeah.
And I think you get a calculator too.
But then again, there's Mark, who
Yeah, in your head.
is like Newton, and he probably calculates logs at home when he's bored.
I have more important things to do. Cartoons.
Oh. Let's get serious.
Newton didn't have a TV or else we wouldn't have all this stuff.
I was going to say, Newton needed the TV.
Okay, kinematics would be question 1, I believe, on there. We'll get to that in a second, Mom. I believe, again, at some point in either your physical science, your some class 7th through 9th grade, the basic equation for kinematics is distance equals, you know what the line over a V means? Average. Average
Okay.
speed times time. Okay? So if you drive on the freeway at an average speed of 80 miles per hour,
Shame on you.
what?
Shame on you, first off.
75, I'm not speeding too much.
Too much.
Times, make sure another common trick is to put the wrong time in there. So if this is hours, you need it in hours. Times 3 hours, obviously how far did you drive?
245.
240, yeah. Okay? Some slower responses there. So this always has to be average. There's 2 types of speed. There's average, of course, and then there's instant. A good example of this, obviously I've done this for physics classes because it comes up enough. If I calculate how far I drive and then how much time it takes me to get here since I live in Ogden, I come out to about 54 miles per hour as my average. Now, I take the freeway. How in the world do I get 54? You know I'm not going 54 on the freeway. I'll
Yeah.
get murdered.
Because you have to drive through town.
Yeah, I have to go through Ogden, get there. So I'm including in this all the times that I'm going 0 if I get at a stoplight. 25 out my street, all that stuff.
If you go 25.
We have a lot of little kids, and
Oh.
that's about the time they go for the bus. So I usually go about 15 on my street, because we also have 3 sheriffs on my street. I don't speed on my street. Anyway, so average includes the whole range of time versus instant would be I take a speedometer reading, whatever, of what I'm actually going at that time. Okay? That makes sense? Pretty straightforward. Okay, now let's see what kind of question do they have there. I believe they give a little bit more.
Number 1.
Yeah.
Okay, a ball rolls down a hill with a constant acceleration of 2 meters per second squared. The ball starts at rest and travels for 4 seconds before it stops. How far did the ball travel before it stopped?
Okay, now obviously I look up here and go, there's no acceleration, right? This is very simplified. I'm just dealing with, I'm given speed and time. I could actually figure this out using this, but a little bit simpler. And I'm trying to just give you the basics, considering when is
The
this?
16th.
16th? Oh, okay, it's not like tomorrow.
No.
Yeah, Davidson's like, you need to come now.
Well,
Fridays are easy because my husband has a day off, then I don't have to go babysit.
we're kind of booked until then,
Oh,
other than the 4 days before.
because then you'll be cramming like crazy?
Or resting, whichever you prefer.
Oh, okay, there you go. Just to make it easier, and just cut to the chase, this is the formula that you would use. A here is acceleration, T is time. VI would just be your initial velocity. Time plus DI here. Anytime you see an I subscripted like that, it means initial. So that would be, usually this you're not going to need, but you'll find an occasional problem where they'll say, here's the 0 mark, you start at 10, for whatever reason you got a head start, and where are you by this time over here? So obviously you started here, so I'd have to add on that extra 10 that I had as an advantage. Anyone see the zombie race in Ogden?
Heard about it.
Heard about it? Yeah. The human got a head start. I wasn't taking a kid to that. Do you guys have any idea what I'm talking about other than Mark?
I would assume
I
that the
think I saw
humans
it
would get a
somewhere.
head start because that doesn't make sense for the zombies to have a head
Yeah,
start.
yeah, the thing was, they gave you were supposed to show up for the race, and half of them were zombies, half of them were humans. And then, yeah, the humans got a head start of like 5 minutes, and then the zombies had to like run after them. It was just for fun.
It was like a 5K or something.
Yeah, it
Yeah.
was something just
We
for
talked
fun.
about it in
I don't-
seminary.
Okay. Most times, this isn't going to apply just because they're saying you start at the 0 mark. Very rarely in a race would you start not at the 0 mark unless you've got some serious ins with the timekeeper or something. So plugging the numbers in, we've got half times 2, let's see, times 4 squared, plus, in this case, my initial velocity was 0, so 0 times 4, doesn't matter anyway. And then it tells me no initial distance, so assume if it doesn't give you one, that it is 0. So we end up with half times 2 times 16, so
Which
16.
is,
Yeah. So this, we could actually, you can go through and figure this out using this equation. Do you want to see that, or do you just want to leave it at that,
we can just leave it
I
as
just
that.
don't know if I remember that whole
that whole thing?
stinking formula.
What I would point out is it actually looks a lot like the quadratic. Instead of putting a t there, make it an x. So it's something x squared plus something x plus, you know what I'm talking about?
Mm-hmm.
Sometimes that helps people remember it a little bit. Yeah, sorry, at this point you just pretty much.
With
have to-
kinematics, what's the acceleration of gravity?
It's assumed to be really, really close to 9.8 meters per second squared.
Okay.
That's the what? Force of gravity?
That is, I believe, yeah.
Okay.
I believe given your, so let me stand it again. I know I had this at one point, and I either tossed it or
Know it all.
where it is. Yeah, gravity would have to fit into this section because it doesn't really apply to the other ones. So the idea here is if I drop an object from rest, so this is t equals 0, this is a ball I'm dropping, whatever. At t equals 1, so 1 second later, it is now going 9.8 meters per second. At
Squared.
t equals 2, go ahead.
Squared?
Second squared.
Second squared.
Nope.
So-
This is the acceleration,
So,
this is the speed.
Monkey's uncle, alright.
Okay. T equals 2, it's now going to be going 9.8 times 2, which would be 19.6. What am I going to do for t equals 3? I can't do it.
Square 19.6.
No, just add the
No.
19.6.
Each time I'm adding 9.8.
Okay.
And you constantly accelerating?
Yeah. And so you have to use that formula to figure out how far you've actually
Isn't
gone.
there a certain speed which it stops?
I always-
Accelerating?
Depends on the object,
Yeah.
but yes.
Terminal
Is it just because of
velocity.
the friction of the atmosphere or what?
Friction
Yeah,
normally.
starts pushing enough
Like you,
up that
you,
it
you will,
picks
if you fall from an airplane at 20,000 feet, rest assured you will only hit the ground at 180 miles per hour.
That's
You didn't know this popped
up.
up.
Only. That's a common.
That's terminal velocity, supposedly 180 miles per hour.
180 miles per hour, which takes you,
That's
what is it?
assuming if you are wearing like a streamlined suit
Yeah.
and you are.
Yeah.
You've seen a racer with Arnold
Oh yeah.
movie made where he like does a little.
Where he has his little bat suit or whatever.
Well, you never wear a cape. I don't remember what he's wearing, but no, he jumps off the plane and like, and catches up with the backpack that somebody threw out that has the. You are all looking at. Okay, maybe you
Wait,
weren't alive.
no,
when
that's
it was-
like,
I've seen a video of a guy
It's
who
like
jumps
when
off and he has like a
Batman-
suit.
it's like when Batman jumps out of the window
and he floats down.
and catches Rachel before she hits the
In the dark
car.
night.
Yeah.
Okay, yeah. I have seen them and I just don't remember it.
Okay.
Anyway, so the number that you quoted, I believe, is if you are wearing a streamlined suit, you wouldn't want the little wing things because that would actually slow you down more. And you would make your body as compact
So
as
we
possible.
want to go fast now?
In that movie, he did want to go fast because
Okay.
somebody threw the
Parachute
chute out,
thing.
yeah, ahead of him, and so he's like, "Oh, I'll catch up with it."
And if you weighed like 5,000
It's
pounds,
crazy.
would you be slower or faster at terminal velocity?
Maybe I'm gonna invent a sport.
Um,
Throw the backpack.
Would you
back,
eventually
have
get
to
to
catch up.
180
Okay.
pounds?
It depends on
That would have a
density.
higher
Here's, it
fatality rate.
depends on your shape and
Dense-
the other things.
and density,
You ever done
yeah.
the very common feather versus penny
Yeah.
thing? Even if, now those don't obviously weigh the same amount. It has nothing to do with weight necessarily, it's all about your surface area. So since the penny just has a better construction, it is going to end up going faster. I have a video, it would take me a while to pull it up, so we won't try.
Cool.
Of one of the astronauts who landed on the moon, he has a feather and a hammer, and he drops them, and they land together.
Huh.
But of course, on the moon, no air resistance. But it is a very nice, you can see them falling down each other. Also, in the old building, I did this, I got in trouble, so we don't do this anymore. I climbed up onto the roof, and we dropped a watermelon and a cantaloupe, and they fell together. But if you keep them pretty compact, it doesn't matter how much they weigh. They will fall together. As long as you get rid of air resistance. And that's why it worked on the moon. Okay, 9.8 each time. So t equals 3 seconds would be 29.4?
Yep.
Yeah, look at my addition skills. Yeah,
Well, you're just adding.
yeah, I know. So I said my addition skills.
No, I know.
Yeah, you're just adding 9.8 every time. What you're going to notice, though, is because you're moving faster and faster and faster, as you are going, if for whatever reason you're, I don't know, dropping something really heavy that's going to stick to the floor when you drop it, what is the pattern going to look like? Is it going to be evenly spaced, or
No.
what?
Don't the waves jet out bigger as they farther they jet out?
Okay, since I'm going faster and faster each time, if I made a dot when I started, and then I made a dot at 1 second, and then I made a dot at 2 seconds, that is totally going down, deal with it. Dot at 3 seconds, what's happening each time?
They're farther apart.
Yeah, they're going
Going down.
further and further. Yes.
I'm just kidding.
So at like 1 second, it hasn't traveled 9.8 yet. That's how fast it's going. It's traveled what, 7-ish?
5.
5.
So wouldn't it be an exponential, like,
Yes.
Yeah, it-
And each time it is getting bigger and bigger.
but you say addition, not multiplication.
Addition,
she is just adding-
addition for speed.
What's 9.8 times 3? It's still multiplication. It's just
But it's not an exponent.
No.
no,
This
not
is not
exponential.
exponential.
Distance that you're going.
This is distance.
So
This
the graph
is
would
speed.
be, graph would be a line, not a parabola,
Well,
right?
it is an exponential function.
The
Yes.
distance one would be exponential. The velocity one would be.
Okay.
So that's for gravity. Did they do any F equals g m1 m2 over d squared?
Oh, they might have
I
done
have
one.
no idea.